Hello everyone, this is Rahul Shrestha here to present the sixth part of the chapter Matter for class 8. So in our last class, we read that every element of the periodic table has two special properties, namely their atomic number and atomic mass. The atomic number, which is represented here, tells us the numbers of protons present inside the nucleus of an atom for any given element. It also tells us the number of electrons in a neutral atom. So the number of protons and electrons in a neutral atom are equal. The atomic mass given here tells us the total number of protons and neutrons present in the nucleus of an atom for any given element. This means that in a neutral carbon atom, there are 6 protons, which also means that it will have 6 electrons inside it as well. These electrons revolve around the nucleus in different cells or energy levels. Now, depending on the element, an atom can have 1, 2, 3 or more number of cells inside it. Till now, we have discovered atoms having up to 7 shells inside them. These shells are named K, L, M, N and so on. The shell closest to the nucleus has a low energy level, which means that the electrons inside them have low energy, and the cells which are farther from the nucleus has a higher energy level, meaning that the electrons inside them have higher amount of energy. But remember that the electrons does not simply fly around the nucleus randomly. Rather, they arrange themselves in these shells in a very systematic fashion. And this brings us to a very important concept in chemistry known as electronic configuration. As the name suggests, electronic refers to electrons and the term configuration means arrangement or layout, which means that electronic configuration is the systematic arrangement of electrons in the different shells of an atom. Remember that the electrons follow a certain rule known as the 2n square rule to arrange themselves in the different shells around the nucleus. This specific rule tells us the maximum number of electrons that any shell can hold in a given atom. Here, this n represents the shell number which goes from 1 to 7, where the innermost cell is cell number 1 and the outermost is the cell number 7. But the 2n square rule is only applicable to the first 4 shells, as the rest of the shells does not follow this trend. For class 8, we'll study the first 20 elements and concentrate our understanding on these 20 elements only. So according to 2n square, the first shell can hold a maximum of 2 electrons. The second shell can hold up to 8 electrons. The third shell can initially hold 8 electrons, though later on they can hold up to 10 more, giving us the transition elements. In a hydrogen atom, its 1 electron is occupied in the first cell, which is the only shell in its atom. For a helium atom, both of its 2 electrons also occupy the first shell. For a lithium atom, 2 of its 3 electrons are occupied in the first shell, while the third electron is occupied in the second shell. And for a beryllium atom, 2 of its 4 atoms are in the first shell and the rest of the 2 electrons form a part of the second shell. The electronic configuration of these elements can be written in short form like this, where every single number in here represents the number of electrons present in their respective shells. Now this same technique can be used to write the electronic configuration of all the other elements as well. But before we move into that, let us first understand how we actually place the electrons in their respective cells, having given their atomic number. Do remember that even though we represent the atoms in a two-dimensional form, where we show the electrons revolve around the nucleus in a circular orbit or shell, the actual shape of these shells is actually 3-dimensional and are quite complex for an 8th class student to understand. And so these will be covered in your higher grades of studies. Now while making the atomic diagrams of the elements, we start with the lowest energy level first and then add up the remaining cells as per the requirement and the size of an atom. which basically depends on the total number of electrons present in that atom. So after drawing the nucleus, we draw a circle around it representing the first shell. Then we use a dot or a cross to represent each electron, and we can also represent the nucleus with the chemical symbol of the element. Each electron in an atom occupies a particular shell, and the electrons must occupy the lowest available shell nearest to nucleus first completely, before moving on to the next cell. So when we are drawing the electronic configuration, we have to fill the shell in this manner, starting from the lowest energy level first. If we take a lithium atom as an example, the atomic number 3 tells us that it has a total of 3 electrons, so as to balance the positive charge of 3 protons inside its nucleus. Do remember that the atomic number tells us the total number of electrons in a neutral atom. So we put the first electron into the first cell, and then the second electron will also occupy the same cell. But as we already know that the first cell can only accommodate a maximum of 2 electrons inside it, so the third and the last electron will go inside the second cell, which will draw as a larger circle around the first cell. And this completes the overall electronic configuration of a lithium atom. Now this same process will be applied for larger atoms as well. We always start with the lowest available shell, and when the shell is full, the next electron to be added goes into the next shell. And this is all there is. All you need to know is how many electrons can be occupied in each shell. And for your level, as I said earlier, you just need to study the electronic configurations of the first 20 elements. So for these 20 elements, the first cell can contain a max of 2 electrons. The second shell can have a maximum of 8 electrons, and the third cell also has a maximum of 8 electrons for these 20 elements. And the 19th and the 20th electrons goes into the fourth cell. And this would actually represent the calcium atom. Note that each electrons in the diagram must be placed evenly spaced out and should be kept in pairs for easier understanding. Look how the third and fourth electrons are kept closer to each other, forming an electron pair, and so does the fifth and sixth electron and all the rest of the electrons as well. You people should always follow this same technique while drawing your diagrams, as this will make your diagrams tidy and will help the readers to easily count the electrons without any confusion. Now, if we wish to write this electronic configuration in short form, it would be written as 2, 8, 8, 2. This first number represents the electrons in the first cell or lowest energy level. The full stop, which can also be replaced by a comma, shows how the electrons are separated between each shell. The second number tells us the number of electrons in the second shell, followed by the third and the fourth shell. Now I'd like you to practice this technique yourself and try and draw the electronic configuration of a carbon atom. Pause the video, get a copy, and try drawing the diagram. Once you are done, get back to the video again. So this is how the diagram looks like. Carbon atom having the atomic number 6 possesses 6 electrons. So the first 2 electrons will occupy the first shell and the rest of the 4 electrons will go into the second shell. I hope you people got it right. Now, how would we write this electronic configuration in numbers? Pause the video again and try this too. The answer is 2.4, as the first cell here has 2 electrons and the second shell has 4. For reference, I am showing you the electronic configuration of the first 20 elements, but do practice these yourselves for a better understanding. Feel free to pause the video whenever required. These are the elements of the second period, and their respective electronic configuration looks like this. Notice that each one of these atoms has a maximum of 2 shells. Now the electronic configuration of the elements of the third period looks like this. You can see that all the atoms here possesses a maximum of 3 shells. And in the same manner, the electrons present in potassium and calcium are distributed across 4 shells or energy levels. So this was all about electronic configuration for your grade, and I hope you will easily be able to draw the electronic configurations for all the elements up to atomic number 20. I'm done for today. We'll meet again in our next class. Till then, take care and be safe. Thank you.